one thing is very clear, that when the stationary waves are made, the end condition is very important. The end condition. Because at the ends, one thing is constant, that there is a node here, always. That means it doesn't move. This doesn't move. So he says that uh, that the end condition, uh, boundary conditions are that x is equal to 0 are positions of nodes, and requires these conditions require that L is related to lambda by this. So the L is related to lambda. That means on L depends lambda, and and the frequency is dependent on lambda and speed. Okay, and you get this expression. Now, what does this tell you? What does this tell you? What is happening actually? You got a, you got a string. You got a string, and you've got a, a vibrator. It could be an oscillator. You're just, and what will happen is that at some frequencies, that means not at you can change this oscillator. You can change the, you can keep on changing the frequency by a setting. So you can go from 0 to, let's say, 2000 or whatever, because in the graph he's given you uh, 0 to whatever these are the frequencies so the guy with the oscillator will increase his frequency from 0 to 200 to 400 to 600 to 800, but he will observe peaks only at somewhere near here. That means about 150 or whatever, or somewhere here about 300 and what somewhere near here. Now why does it he observe? um, because resonance has happened. Now, what is resonance? What essentially means is that this has a natural frequency. This structure has a natural frequency that matches with the oscillator frequency, and you get a big amplitude. You get a big amplitude. So that only happens at some specific frequencies, not every time. Okay, so the point is that obviously by at those frequencies where the end condition, the speed, the speed and the frequency, the lambda and the end condition decide the frequency. So that's what I was telling you, that there's the L is related to the lambda, and the speed divided by the lambda. The This is B. So V divided by 2 L by N will give you this. This will give you the frequency. Okay, so this is at the point where resonance, the natural frequency of the string and the oscillator match, and then you get a big amplitude. And so this is what is the concept. Now, point he gives you the length 648 mm. So you'll have to convert it to meters. It's 0.648 meters. This is the length. And he's given you the first frequency. That means he's given you first frequency is obviously this one, caused by, we call it the fundamental or the first harmonic. Now at this point, what will happen? N is 1. So that means lambda is 2L and frequency is 1 into whatever. So that is the speed over 2L. And now the speed is also constant, the length is also constant. So this we can just put 1 here and keep this as a constant. So the second frequency will be twice of this, third harmonic will be thrice of this. So that's what he's asking us. He's saying that no, he's asking me the speed. So he's asking me the speed. So the speed comes from this expression that this is 147. So 147 is equal to speed over 2 times 0.64, whatever it was, 0.64. So that 2 times. So you just do this and you get the answer. So uh, you solve this, and that's what he must have done. So this is the length 12. Then he says whatever he does. Okay. So what is he trying? Yeah, he's trying to solve that. 147 and 2 comes to the other side and 0.64. So we get speed is equal to 147 into 2 into 0.648. So that's what he's done. Okay, so now uh, then the next thing. One thing is clear. This is giving you this formula is giving you the uh, first you have the end condition gives you lambda, gives you frequency now, but it requires the speed. It requires speed. Now the speed is not dependent on the oscillator, or the speed is not dependent on the frequency, the speed according to material properties. So that is dependent on only these two things: the tension and the mass per unit length. So that you have to see this tension, speed is this, and mu. So this is mass per unit length. Where does he say? Okay, this is mass per unit length, but yeah, so here he's doing a question. He says, uh, a steel wire is this length, has a mass of this. So you have to divide the mass which is given by the length to get this. So we can write this as V is equal to under root T by mu can be written as mass over length. Okay. So now in that question he's asking you the mass, I think. So he is asking you the tension is given. So it was under root T m by L. So this is given to be 71. Mass is asking, length is 0.648. You were given the speed from the previous part, and then you solve this to get. So this he's doing. Yeah. So uh, where's the working? Can you just calculate it?